In this video, I want to take a deep dive into this Heightfield Erode tool and break down the different parameters and just explain what they do. When I first started using erosion in Houdini, I found a lot of these parameters quite um, bewildering, confusing. There's quite a lot of different parameters to play with, and a lot of them have crossover with them kind of affecting one another and the results of the erosion. Also, if you're coming from software such as War Machine or Gaia, the way the erosion tools in Houdini work is slightly different than what you might be used to. So I have this example file which I will share with the project files, which try to give examples of the effects of the different parameters as well as a kind of bit of a description. I'm just going to go through now and just explain and go break down each example. So there are some similarities between the erosion tools in Houdini and other software packages. So if we look here, I have a height field. This is currently at a resolution of 500 by 500. So that would be, if I was to bake this out, a map with a resolution of 500 pixels by 500 pixels. And we can add noise to the height field and some distortion to kind of give some detail to the noise. And then here I have an erosion, which applies some erosion to the height field. I've got some cache file caches here. So I've already gone through and cached all of the results of my erosions to disk. So if you want to cache them, just select a cache node or select multiple cache nodes at once and click Save to Disk, and that will cache the results to file. So we have this height field at a 500 by 500 resolution, and we have some erosion on it. Typically, when working in other softwares such as War Machine or Gaia, you apply different erosion nodes, different noises, distortion, get a look that you like. You're previewing it at a low resolution, and then you bake it out at a higher resolution. Then you'll get the same erosion, but just with more detail. But with Houdini, when we increase the resolution, we change how the erosion behaves. So on the right here, I have a resample node, which is increasing the resolution to 1000 by 1000. So now this is at a resolution of 1K. So I'm doubling the resolution. And when I look at the results of this erosion, we see while we have more detail, it also looks quite a bit different. So if we look at some of this water area where it's pooling in the kind of basin valleys, at the low resolution, the lakes are quite broad, with quite a lot of water pooling up. But as I increase that resolution, we actually see this less water pooling up. These areas are a bit thinner. Also, these channels and tributaries that are coming down from the valleys, we also get a lot more of them when we increase the resolution. And also the shapes have changed quite a bit as well. And also the debris is behaving differently. So we see on this lower resolution, the debris is slumped here at the bottom of this slope of this mountain. And at the higher resolution, we see that debris is still building up on the side of the slope and hasn't slumped down quite so far. So the resolution of the height field directly affects how the erosion behaves. So when we're working with erosion in Houdini, the workflow is a little bit different. So I have the same setup. I have a height field, I'm adding some noise and some distortion, and then I'm applying some erosion to it. So here I've applied an erosion to a resolution of 500 by 500, and we've got an initial erosion pass. Then when I want to increase the detail and add more detail to this height field, I then use a height field resample to increase the resolution. So here I'm doubling the resolution, the scale of the resolution. So it's doubled to 1000. I can apply some more distortion to add additional detail and then run another erosion. So this way I have all of the detail from the previous erosion, this pooling water and these larger channels and this buildup of debris. And then when I run a second erosion, I add more detail to that existing simulation. If I start on frame 1, I'm going to uncheck freeze frame. So now I'm seeing the first frame of the simulation. And so you can see, to begin with, I already have this debris and water layer in this simulation. And so now when I play this erosion, we see it continue to evolve and continue to simulate, with additional debris and water adding to that existing water and debris layer. So this way we can build up layers of erosion and use resample nodes to slowly increase and step up the resolution until we get to our desired final resolution. Also, if I select this Heightfield over here, let's go back to frame 1 and uncheck freeze frame. Here I've checked reset water, debris and sediment layer, and we can see that's removed those layers from this height field. You can still see the results of the previous erosion. I can see some channels here. The water has flown down from the mountains. But now when I run the erosion simulation, we see kind of fresh debris and water building up on the landscape. So we can see with this example where we've reset the water and debris layers, we've actually got less water building up because I've removed that initial water from the first erosion pass. But that gives me a different kind of look to the landscape. So moving on, I now want to kind of go through the parameters on this main tab here. We have some parameters for hydro and thermal erosion. Here I have this kind of basic landscape. I've just cropped to a smaller section just so I can kind of zoom in and we can focus in on some smaller features. And then I'm passing that through to this object merge, which is then I have plugged into lots of different erosion examples. On this first example, I have just the hydro erosion. So if I select this, you can see here I've turned the thermal erodibility down to 0. So I'm not getting any thermal erosion. We're just looking at the hydro erosion. And so as you imagine, this is erosion caused by water, such as rainfall, which then flows into rivers and lakes and erodes away the landscape. And that creates these river channels that cause these valleys and large lakes and rivers. And then we have thermal erosion. So for this, I've turned down the hydro erodibility to 0. Then under the advanced tab, I've also turned down the precipitation to 0. So we're not getting any rainfall. So here we're just looking at the effects of thermal erosion. Thermal erosion is caused by the repeated heating and cooling of rocks, which causes them to fracture and break down. So this kind of erosion happens in very dry and arid locations. Some of the characteristics of thermal erosion are these sharp ridges and cuts that we see on these peaks, and then this build-up of debris along these slopes. And this debris is also a key characteristic of thermal erosion. It's called talus, and it builds up this kind of slope debris around the base of mountains. And I'm going to go through the parameters for these two types of erosion. So to begin with, we have this erosion rate here. And the erosion rate is a multiplier of the erodability. So currently it's set to 0.2. So that means we have a low erosion rate. So we see some erosion on the landscape. We see some channels here eroded into these slopes, and we see the water building up in the basin. If I increase this erosion rate to 1, we see a lot more erosion. These channels are much deeper, we see more of them. I also see more debris as well because we're getting more erosion, that produces more debris, and so that also builds up on the landscape. we also have a global erosion rate up here as well. And so this is a erosion rate for both hydro and thermal. So what I might do is if I here I'm simulating over 20 frames, so I could work at a um, lower erosion rate and erode slower, but for longer. But if I was maybe working over just 5 frames, then I might increase this erosion rate or increase the erodability to erode faster but stronger over a fewer number of frames. Moving on, we have this bank angle. So to begin with, I've lowered the bank angle, and that results in much less erosion and much fewer channels appearing on these sloped areas. And if we increase this bank angle, so here I've increased it to 90, we get much narrower channels, and these areas also appear deeper. We then have spread iterations. So a lower spread iteration causes the water to spread more slowly, and that results in these thinner and more contained rivers and lakes. And if we increase that spread iteration, then we see that water spreading much further. You can see it's kind of not staying contained in these river channels. It's spreading more quickly and it's spread further in these kind of lakes and larger river areas. Moving on to the thermal erosion. So these have some similar parameters. We have the erosion rate of the thermal erosion. Again, that's a multiplier of this thermal erodibility. So with a low erosion rate, we see some erosion. We see these kind of sharp peaks and ridges, and then a build up debris on the slopes. So if I increase that erosion rate, we then see more erosion. You can see this ridge has become much sharper. We've got these much more sharper cuts and more debris building up on the slopes. And then we have this cut angle. So here we have the default cut angle of 35, and essentially any slopes under this angle um, won't be eroded. So as we increase this angle, so here I've increased it to 65, we actually see that stops the erosion on the slopes. And keeping that cut angle the same, here I've added a Highfield remap to increase the angle and the steepness of these slopes. Still, with a cut angle of 65, we now see we're getting some erosion on these steeper slopes. So again, we can see some crossover between these parameters. We have the erosion rate. We increase this, we increase the erodibility. But then also, if I decrease this cut angle, I'm also going to cause more slopes to be eroded. That'll also increase erosion. So that covers the parameters under the main tab. Moving over to the advanced tab, we see we have even more parameters to play with. So we have parameters to tweak different aspects of the hydro erosion, parameters for the thermal erosion, parameters to control the precipitation, so the amount of rainfall, and then some parameters to tweak and adjust the water and debris flow. So moving on down here, we have these parameters under the hydro erosion. To start with, we have the removal rate, and this is the rate at which debris is removed from the simulation. So each frame, a small amount of debris that's caused by hydro erosion is going to be removed from the simulation, and that simulates debris being swept away by the moving water. So here we have the default removal rate, and then if I increase it, so here we've got a very high removal rate, we see much less debris building up on the riverbanks. And also you notice we've got much deeper channels. So we're also seeing a lot more erosion. And that's because debris also inhibits erosion. So here we have the same amount of erosion, the erodibility is the same, but because we have more debris, that's inhibiting erosion. But if we remove it, we get much deeper channels as there's less debris to kind of slow down and inhibit the erosion. So this is something I play with quite a lot and something that's good to bear in mind. You haven't just got to increase erodibility to get more erosion. You can also play with some of these other parameters to kind of increase these incisions. And if I was to add a negative value to the removal rate, then I actually add debris to the simulation each frame. So this is increasing the amount of debris that's being generated each frame of the simulation. And because I'm adding debris, I'm also reducing the amount of erosion. If I actually compare it to the landscape before the erosion, you actually see there's not much difference between the two. We can see maybe some depth in some of these channels up here, but most of all, it's staying the same. We just see this water and debris building up on the landscape. Moving on, we have the max debris depth. And so with a lower amount, we don't see much erosion on the landscape. We see some water pooling, but I don't see much debris and I don't see much erosion in these channels. But if I increase that max debris, then I start to see some of these channels becoming eroded and deeper. The erosion stops when this max debris depth is reached. And so because I have a very low value, that max debris depth is reached much quicker, and so I see much less erosion. But if I increase that debris depth, then the erosion can continue for longer, building up debris, and then once it reaches this much higher max debris depth, it then stops. So a higher debris depth results in more erosion and deeper channels. Moving on, we have grid bias. So this controls the direction of movement of the hydro erosion. So I'm just going to read the description that I have here, which is from the help documentation, and then I'll show the different examples. So this controls how biased the movement of material is. A positive value would bias the movement in the direction of the principal axis. A negative value would bias the movement at angles of 45 degrees relative to the principal axis. The default value of 0 would be no bias in any direction. Now, I don't really change this parameter all that much. If I look at the examples, with a negative grid bias, look at some of these channels, we can see them almost moving in straight lines. So here it takes like kind of a 90-degree right angle, and we see these straight lines flowing down these slopes. So with this negative bias, we see these very straight lines. They almost ignore the flow of the landscape, and it just kind of cuts straight through. If I use a positive grid bias, so you have a positive 0.5, then I also see straight lines, but it's kind of biased in the other direction. And then if I have the default of 0, then I see these kind of more natural winding rivers and channels. So I don't really play with the grid bias too much. There might be a use case if you want to move or change the look of some of these channels, then this grid bias can kind of adjust the direction of flow. Now I'm going to go through some of these other parameters under these tabs. So first of all, we have erodibility adjustments. So to begin with, we have the ramp up iterations. So here I have the default ramp up iteration set to 5, and then here I've increased it to 70. So we're not seeing a great deal of difference. I am seeing less erosion with the ramp up iterations, You can see here I've got more buildup of debris as more erosion is happening with the lower ramp up iterations. And so with this value, the erodability will ramp up over this number of frames or this number of iterations. So to begin with, it will have a low erodibility, and then over the course of 5 iterations, it will slowly ramp up until it reaches its full erodibility. And that's this erodibility we've got set here under the main tab. So when we increase that to ramp iteration of 70, it's then taking much longer, a lot more iterations to ramp up and increase hit its full erodibility. So that results in lower erosion. So this might be useful if you want to do kind of your initial erosion. You might want it to erode much faster, much more quickly. Then you would decrease its ramp up iterations or set it to 0 so that it's its full power from the first iteration. So if I was working with much fewer frames, then I might want to set this to 0 so I get a much more powerful erosion over those fewer frames rather than waiting for it to ramp up. We then have initial factor. I struggled to fully understand what this exactly did from the help documentation. My interpretation was that it sets how much the erodibility affects the initial movement of debris, and it would increase over the set spread iterations until the max iteration, where it would stay at its maximum set value. So I think this works similar to the ramp up iterations, but for the spread of the water. If I actually look at these two settings, so I have the initial factor of 0.2, and then I've increased that to 0.8. And the results are quite subtle. I believe with a higher initial factor, you get more movement in the debris and water faster. So again, if you're working with fewer frames, you might want to increase this initial factor so you get more movement in those smaller number of iterations. Moving on, we have slope factor. And so this affects how these slopes are eroded or how much the slopes are eroded. So with a lower slope factor, we see more erosion on the slopes. So on these slope areas, we can have lots of small channels that are quite deep. And then if I increase that slope factor, then we start to see less erosion on the slopes. So if I wanted to see deeper channels and valleys, I would decrease the slope factor to get more erosion in these areas. Moving on, we then have some settings that affect the erosion of the riverbeds. So we have an erosion rate here as well. So increasing this will increase the erosion, but just in the areas of the riverbeds. So with a low erosion rate for the riverbeds, we see a lot of water runoff, but we don't see many of these channels holding water or much erosion. But if we increase this value, this erosion rate for riverbeds, then we see much deeper channels and incisions from those rivers. We then have this deposition rate, and so this controls the rate at which the sediment turns into debris. Again, this is another parameter that I don't really play with that much. At its default value of 0.01, we see some debris buildup, we see some water channels, but as we increase the deposition rate, we see much less erosion and more water runoff into these kind of lakes. So I think what I'm seeing here is that at a lower deposition rate, I'm seeing less sediment turning into debris. And because debris inhibits erosion, when we increase this deposition rate and turn more of that sediment into debris, I then see less erosion. That said, it's a bit unclear because I'm not necessarily seeing more debris on the surface. But that perhaps that's because the debris is actually being contained in these rivers rather than on the riverbanks. And then we also have some erosion settings for those riverbanks as well. So again, erosion rate, this is just the rate of erosion on the riverbanks. At this resolution, the effects of this parameter are quite low. I don't see a great deal of difference. Perhaps that's because the riverbanks at this resolution are quite small, so I don't expect to see much difference on how those are being eroded. But a higher value, you would see wider river channels, as you would see those banks being eroded more. So I do see more debris building up along the river banks, possibly because that's where more erosion is happening. So that covers all of these parameters under this hydro erosion. Let's now look at this thermal erosion. So this has some similar parameters to this hydro erosion. We have removal rate, and that is the removal of debris, sorry, the rate of removal of debris caused by thermal erosion. So if we have a look here, I have a low removal rate, a value of 0.2. So we see this debris building up. If we increase that removal rate, we then see more of that debris being removed. And this simulates debris being swept away by wind. And as I said before, debris inhibits erosion. So with the increased removal rate, we see more erosion happening on these slopes, as there's less debris to kind of protect the landscape from erosion. We also have a max debris depth for the debris from thermal erosion. So the higher the max debris depth, then the more erosion that we get on the surface. So as I increase the max debris depth, we then see more erosion. So we just see this slope here become steeper as I increase that max depth. So again, that's because when the max debris depth is reached, the erosion stops. And with the higher depth, erosion can continue for longer, and it takes longer to reach that max depth. And then we also have a grid bias as well. So again, this biases the direction of the erosion. So we can see these kind of cuts occurring in one direction with a negative value, and then if I change that to a positive value, we see those cuts changing direction. And by default, that grid bias is set to 0 and has no bias in either direction. And again, most of the time I have this set to 0. You may just need to maybe tweak this bias if you want to just subtly adjust the direction of those erosion lines. So that covers these erosion parameters. And next I'm going to talk about this precipitation parameters. And precipitation is the amount of rainfall on the landscape. So here we have the default amount of 0.2, but if I increase that amount, we then see more rainfall and more water building up on the landscape. And obviously, because there's more water, that means more water to cause hydro erosion, and we get much deeper channels. And then also more water running off into this basin. Can also increase the density of the rainfall. So the higher the density, the more tightly packed the raindrops. So this has a similar effect to increasing the amount of rain. We again see more water, so that means more hydro erosion and more water to fill up the basin areas of the landscape. And with a lot of these parameters, you can also add masks. So this way you could cause more rain to fall in some areas compared to others. So for instance, you might want to have more rainfall on the kind of mountainous areas, which then flows down into the basins. Where there's less precipitation, we just want to see more water building up from the rainfall that falls on the mountains. And this way we can kind of direct how this precipitation affects and erode the landscape. And then we have the evaporation rate, which works very similar to the removal rate for thermal and hydro debris. So this removes water from the landscape. So with the evaporation rate set to 0.04, a small amount of water is removed from the simulation each frame. If we increase that evaporation rate, then we see much less water staying on the landscape. We still see the effects of the erosion, we still see the channels appearing, we still see debris at the bottom in these valleys, which is a result of the hydro erosion, but that water isn't staying on the landscape. Instead, it's evaporating and being removed. So again, you could use it in conjunction with the precipitation amount. So you want a lot of water, you want a lot of hydro erosion, but you don't want that water pooling and staying in this basin. Increasing that evaporation rate will remove that extra water that you're adding when you increase the precipitation amount. And then we have some settings for the raindrops. So we can expand the radius of the raindrops. So here we have the default value of 0. But if I increase that radius, so increase it to a radius of 3, we see much wider channels in these valleys, and again, these wider rivers and lakes in the basin. So this works, this almost has a similar look to increasing the precipitation amount or the precipitation density, but instead it just almost broadens and widens the existing channels. And then we have the raindrop blur radius, which at this resolution doesn't have much of an effect. Um, but at a higher resolution, I would expect the kind of edges of rivers and lakes to appear softer as you blur and smooth out the raindrops. And then moving on, we have water flow. So under water flow, we have a setting for quantization, and this is the chunkiness of the water. So at the default value, we see smooth flowing water with these kind of smooth channels. But as we increase the quantization, we get a much more kind of noisy and chunky, kind of broken up edge to these rivers and channels. So these might not look very natural, but maybe we can think about them more as maybe slow moving glaciers, which are much larger, but also have very large amount of erosional force on the landscape. And maybe we can even think about glaciers from ice ages that have kind of come and gone and the ice has melted, but we just see the remnants of these valleys carved by these very large glaciers. And then we have much more recent rainfall and rivers that have formed and then erode that landscape further. So this maybe could create some kind of interesting features that we could then layer additional erosions on top of. Moving on, we then have some parameters to control the debris flow. So to begin with, we have the spread iterations, currently set to a default of 10. And if I increase that, we see the debris kind of spreading um, further. So by increasing the spread iterations, we're increasing the number of iterations that the debris algorithm runs each frame. So a higher value results in the debris kind of spreading further each frame. So where we see debris kind of slumped high here on these slopes from thermal erosion, and then some debris building up these channels. If I increase the spread iterations, I then see that debris moving further down these slopes and building up more in these channels. And then we also have quantization parameters for the debris. So again, this controls the chunkiness of the debris. So here the debris is kind of very smooth. We increase the quantization, we see something that's a lot more chunky and it's got a lot more noise to it. So maybe this is debris that's less fine, less broken down, such as maybe larger kind of rocks and boulders. Moving on, we then have water absorption. So this isn't a parameter I play with too much, Reading from the help documentation, so controls the movement of the debris based on the last frame's flow field. Higher values would stop the debris from moving near the flow channels, and lower values would cause the debris to ignore the flow channels, making it move independently. So my interpretation of that, and just seeing the results from playing with the water absorption parameters, a lower value results in the debris moving more independently of the river channels, whilst a higher value results in the debris moving less near river channels and building up more on riverbanks. So if we look at these two different examples, the differences are quite subtle. We see some of these channels behaving differently at the increased water absorption. So the way I see this is that a higher water absorption results in more debris building up on riverbanks, whereas if with a lower water absorption, more debris is kind of being swept away into the rivers, as it's able to absorb more water. And then we have debris flow max height, and this parameter is also kind of works in conjunction with the water absorption. So the maximum height of wet debris that would not move due to water absorption. Beyond this limit, the debris starts to move again. So a lower value results in the debris near rivers moving more because the debris is reaching the max height quicker, and once it reaches the max height, it then starts moving. Whereas if we increase the max height, the debris builds up for longer before it starts moving. Again, the results of this are quite subtle. Perhaps at a higher resolution, we'll see a more obvious difference. And then moving on, we have this repose angle. With this, I have just thermal erosion switched on. I've turned off precipitation and hydro erosion. And so with the high repose angle, we see more debris on these higher slopes. If we decrease that repose angle, we see it slumped kind of lower. So this parameter sets the maximum slope at which loose solid material will remain in place without sliding. So a lower value results in less steep piles of debris, and a higher value results in steeper piles of debris. And this is particularly key for debris caused by thermal erosion. And just to illustrate that, um, here is a good example of that repose angle. So if we imagine more debris being added to this pile, we've reached a point where the pile is so steep that any additional debris will just simply roll off and build up at the bottom. And so this is a characteristic of this talus debris that we see with thermal erosion. We see this repose angle, and any additional debris that falls onto these piles simply rolls off as it's reached its maximum angle of repose. And so that's the last parameter under this advanced tab for the Highfield Erode. So that's been a very kind of quick whirlwind look at the parameters on the Highfield Erode. For me, it took a lot of kind of trial and error, tweaking, going backwards and forwards, trying different combinations of these parameters. If you're trying to design a landscape, I highly suggest collecting as much reference as possible and then try and kind of tweak and adjust these erosion settings to kind of get the look and feel that you want. And then perhaps if you're not getting the right amount of debris or the right look of the erosion, hopefully now you can start to consider how to change these parameters and what some of the effects might be. Rather than when I first started, I was kind of just punching in random values and trying to just see what the different effects were. And in particular, the differences between hydro and thermal erosion. So you can understand how in different parts of the world you might get different types of erosion, and then you can kind of tweak these different settings to maybe reduce hydro erosion in very dry and arid locations, or maybe decreasing the thermal erosion when we're just concerned with hydro and water erosion. So I just encourage you to have a play and then come back to these examples when you want to kind of refresher and reminder of what these different parameters do.